Here's a closer look at the date time range value object we created. A value object doesn't make sense on its own, so you can see it's used as a property in the appointment type. Let's take a look at the code for some important concepts of how to implement a value object.
The DateTimeRange class inherits from value object. Both of these types are located in our shared kernel because of the fact that we could use them in multiple different bounded contexts within our application. Looking at the DateTimeRange, the first thing you'll notice is that it inherits from value object of t. If we look at that type, this is a class that Jimmy Bogard wrote, and you can find it at the URL shown here. The benefit of using this base class for your value object is that it implements IEquatable of t and also provides you with overrides for equals and get hash code that will automatically, through reflection, take a look at the different properties that your value object has and compare each of them to determine whether or not two value objects are equal.
One thing to point out about this class, however, is that it doesn't take into account the possibility that your value object has a collection property. Now, we're knowingly using this because so far we don't have any value objects that have collection properties.
Okay, so looking back at DateTimeRange, one of the things to note about this is that we've made it immutable. Now, unfortunately, C# doesn't have any built-in language support for immutable types, but we can achieve the same thing by making sure that our properties don't have any public setters or any other way for the user to set the state of this object once it's been created. We provide whatever state this type needs in its constructor.
And notice that we have two different public constructors. The first one is kind of obvious. We pass in the values for a start and an end time. But as we were building it, Steve had a very good idea to take into account scenarios where we might have a start time and a duration. So if we're creating an appointment, we know that it starts at 10 a.m. and it's a half an hour long. Well, this lets us pass in that information, and then the constructor itself will set the value for the end date based on those two values. You just heard Eric Evans talking about having methods in value objects that can provide additional logic that the value object can be responsible for. As an example of that, we've got this duration in minutes method that lets us easily find out how many minutes a particular date time range represents. As we evolve our application, perhaps we'll want to add a duration in days or duration in hours, but right now duration in minutes satisfies all of our needs. The other methods I want to point out are similar to some of the string methods we were talking about. Remember, the string methods return new instances of the string based on the existing string plus whatever logic the method you asked for performs on it. So we do the same thing here. For example, with new end, we might need to change the end time of a date time range on, for example, an appointment. So since this is immutable, we're not going to change the end time, but we can say, hey, date time range, we need a new one that looks just like you, except the end time changes. So all we have to do is call this method, pass in the end time, and it returns a whole new date time range instance for us with a correct start and end time. And so we have other methods that allow us to do this in different ways.
And then the other value object that we can point out here is animal type. This is just to give you an idea that your value objects can be extremely simple. In this case, animal type is just a combination of the species and the breed of a particular pet or patient that we're dealing with at the vet clinic. And there's not a whole lot of other behavior here, but it does provide us with a container for encapsulating these two related properties together as a single value object.